So basically today we'll be talking about the importance of complex number and why we need to study complex numbers. Now essentially when we talk about certain quadratic equations or polynomials in general, there may be certain situations where the solution of that particular polynomial or quadratic equation is not present in the real number line. So let's say I am considering a quadratic equation, a very simple one. Let's take x square minus 1 equal to 0. It's a very easy quadratic equation. I can solve it as follows. So x square equal to 1, and naturally x is equal to, just write that properly, x is equal to plus minus 1. So that is a very easy quadratic solution, the solution to a quadratic equation. Now this belongs to the set of real numbers, so this poses no threat to the knowledge domain that we have up until now. The problem arises when, let's say, we consider an equation x squared plus 1 equal to 0, right? So essentially, initially we had taken the equation x square minus 1 equal to 0, and now we have taken the equation x square plus 1 equal to 0. A slight modification in the sign of the constant, and that actually creates a lot of problems. So let's see what the problem is all about. So if I rewrite that, I can rewrite that as x square is equal to minus 1. Now x square is a square number, so let's say x is positive. If x is positive, then x into x is a positive number multiplied by a positive number, so that gives me a positive number. Plus 2 into plus 2 is plus 4, plus 3 into plus 3 is plus 9, so that's also a positive number. Essentially the square of a positive number will be positive in itself. But if we take negative, the square of the negative number will also be positive. Minus 2 into minus 2 is plus 4. Minus 3 into minus 3 is plus 9. So whether it be positive or negative, whether the original number is positive or negative, its square will always be positive. However, for this equation that I have here, I have x squared equal to minus 1. That is, I'm getting a negative square number. Essentially, what do we mean by solution? A particular value of x which satisfies this equation, right? But I cannot think of any real number, at least. I cannot think of any real number that satisfies this equation x squared equal to minus 1. Because in that case, I'll have x is equal to root over of minus 1, which makes no sense because minus 1 cannot be a square number. So how do I root over of that? Now, what mathematicians came up with is they called this something I. It's an imaginary number. Let's say it's in something out of the realms of reality, and let's say it's an imaginary number. So this is the value of I. So if somebody asks you what is the value of I, you say that's square root of minus 1. It doesn't have a value as such. If I talk about other numbers like pi or e, this I cannot exactly be defined or explained in the real numbers that we know of, because pi is a real number. It's not rational, but it's still a real number. E is also a real number, so we can give a sort of an approximate value for these two numbers because they are part of the real domain. But I is not exactly a real number. I cannot perceive it. I cannot imagine it. It's an imaginary. I cannot. Well, I can imagine it because it's an imaginary number, but I cannot perceive or sense it in the real domain. So this is the concept of I. Now, does this concept of imaginary number stop right here? Can we expand the concept into broader perspectives? Sure. Let's say I take an equation, again, an easier one, but let's say it's a little bit complicated. So let's take the equation x square plus x plus 1. X square plus x plus 1 equal to 0. I don't know if it'll give me the solution that I want. If it doesn't, I'll have to change the equation to suit my needs, but let's see. Now I know of something called the Sridhar Acharya formula. Do pardon me if I make spelling mistakes, but I'm pretty sure this is the spelling. I'm not sure though. We have something called the Sridhar Acharya formula. If I use that, I'd get the solution to be x equals minus b. So if I compare this to ax square plus bx plus c equal to 0, I get a equal to 1, b equal to 1, and c equal to 1. So I could have written a equal to b equal to c equal to 1. So this is what I have. Now, what if I apply the Sridhar Acharya formula to get the solution? So x is minus b plus minus root over of b square minus 4ac. So 4ac is 4 into 1 into 1. So let me just write that as 1 minus 4 by 2a. So that gives me minus 1 plus minus 1 minus 4 is minus 3, so root over of minus 3 by 2. Yes, this gives me a solution which again cannot essentially be defined in the real domain, because minus 3 can never be a square root. So I cannot put a minus 3 cannot be a square number, so I cannot put a square root over it. So essentially this again cannot be explained in the real domain. This number does not belong in the set of real numbers. Now what do I do with it? Do I just leave the sum? Do I adjust the equation? Do I do something? Well, what I can do is, let's just isolate the solution. This is one part. The other part is plus minus half. Instead of root over of minus 3, I can write it as root over of minus 1 into 3, because 3 is minus 3 is basically minus 1 times 3. So I can rewrite this as minus half plus minus root 3 by 2. Root 3 by 2 is again a real number, so this part poses no threat. Root over of minus 1. This is the part that, well, is bothering us. So let's rewrite this again. This time, instead of minus 1, I'll be replacing it with I. So we have minus half plus minus root 3 by 2 times I. This is actually a complex number. Now, what is the difference between a complex number? Before I explain that, let me just write that. This is a complex number. Now, the difference between complex number and imaginary number is that a complex number has two parts. So let me just write that now. A complex number has two parts. The first part is the real part, and the second part is the imaginary part. So essentially, a complex number consists of two parts, the imaginary part and the real part. What do I mean by the imaginary part? This is the imaginary part. And if I want to mark let me just mark it here. And if I want to mark the real part, let me do it with blue, so I can mark the imaginary part and the real part. This is my real part. So when we talked about minus root over of minus I, that was essentially an imaginary number. This is an imaginary number. This is a real number. When I combine these two, they are like two sisters. When I combine these two numbers, and we get something called a complex number. So a complex number has two parts, real part and an imaginary part. Essentially, this existence of a complex number solves the dilemma of solving more complicated quadratic or polynomial equations like x square plus x plus 1 equal to 0. We up until now we would have stopped right after solving x to the power 2, that is x square minus 1 equal to 0. We wouldn't have been able to solve x square plus 1 equal to 0. Neither would we have been able to solve x square plus x plus 1 equal to 0, because the solution to this crawls into the domain of complex numbers. We wouldn't have been able to do that with the knowledge that we have up until now. When we introduce the concept of complex numbers, we can solve more quadratic or polynomial equations, and that expands our knowledge domain. And that is why essentially we need complex numbers.